Hi there, guys. Question 7. We have this biscuit tin. This looks like a pretty tough question, and I'm sure it is. And actually, because there's so many, what I'll do is I'll only show you the video for those, and we can ignore these, and we'll catch up in the next video. Okay, so we've got to show that the volume is equal to this expression here. Now, the volume of and it's just a tin, okay? So the volume of a tin is just a cylinder, so that's pi r squared, the cross-sectional area, times the height. This is where our first problem is. So this would be the height. We don't know what the height is, and in this expression there is no height, there's no h, or h, however you pronounce it. That doesn't exist, so that's our first job. We have got to find an expression for h. Okay, so let's look at the question. So we're told that this is a lid, so this lid is going to go over this biscuit tin, which means that this is empty. Okay, this is hollow, and that's really important. That's an easy mistake to make with this question. So this lid goes on, and this 1 centimeter overlaps, and they're both made out of one sheet of metal, which is 80 pi centimeter squared. So if you think about the construction, what we're looking at here is surface area. So let's have a look. So surface area. We've got two things, so we'll go with the tin first. Now the tin, that's made up of this circle here on the bottom, so it's going to be pi r squared. But we know what r is, that's x, so pi x squared. Plus this curved surface area. So if you're unsure, get a piece of paper, fold it to make a cylinder, so roll it rather. And you should see that this length all the way around here represents the length of your rectangle. And the length all the way around is the circumference, which is pi d, which is pi, diameter is 2x. So there we go. We're going to times that by the height, which we still don't know. Okay, so that's the tin. We're going to add that to the lid. And the lid, that also has this circle, so that's pi x squared or pi r squared. R is x. And we also have this curved surface area here as well. So it's still pi d, so that's 2x, but this time we know this length is 1. Times that by 1, it doesn't change, so let's leave it like that. And we're told that that is equal to 80 pi centimeter squared. Okay, so let's divide everything by pi. Pi is in every term, we can do that, no problem. So let's just cancel these out. So divide everything by pi. So what we've got here, I can see here that I've got x squared plus x squared, so I'm going to have 2x squareds plus 2xh plus this 2x, and that's going to be equal to 80. Now everything here is also in the 2, so let's divide everything by 2. So we're going to get x squared plus xh plus x is equal to 80. Now we wanted an expression for h, so let's get that on its own. So here's the term with it. Let's get everything else on the other side. So we're going to have 80 minus an x squared minus an x. Now, to get this on its own, I have to divide by x, so just pop this down a tad. Wait for my extremely slow computer. So that's going to be 80 over x. Now, x squared divided by an x, well, that's just an x. And x divided by x, well, that's just a 1. So there we have it. Oh, I'm silly. I should have divided that by 2 as well. So that's going to be 40. So just sorry about that, guys. You're probably shouting at the computer that I've made a mistake. I know some of you like to do that. Okay, so here we go. So now we can hopefully put this expression in for here, and it gives us our answer. So let's do that. So volume equals pi r squared Now again, r is not in here, so they're using this x, so let's just change that for an x. There we go. Times this, so it's 40 over x minus an x minus a 1, and we just got to, you can see that they've only got pi outside, so let's expand this and then refactorize it. So we're going to have 40 pi x squared over x, I'll deal with this in a minute, minus pi x cubed minus pi x squared. So they're going to cancel, and you can see here there's no fractions, so that's good. Let's take pi out because that's what they've done there. So pi is going to be 40x. It's looking good so far. Minus x. Okay, so these two terms the other way around. It doesn't really matter, but because it wants to look exactly the same, that's what I'm going to do. But they've had that term first. I don't really like that. I'd rather have it in ascending order, so really I'd rather have the cubic term here, the cube term, then the squared term, then the linear term. But because I started with this one, it is good to write it in ascending order. Okay, there you go. So it's a pretty nasty question, guys, but hopefully you've understood that. Okay, so we're told that x can vary, so this value here can vary, and we have to find the positive value for where v is a stationary point. Okay, so what that means, volume, say it's like this, and so here we have v, here we have x. This x value can vary, and when it's stationary, it's here. It's kind of like the maximum as well. I'm assuming it's maximum. Actually, looking ahead, this is talking about maximums, so it's going to look like this. And actually, that's obvious because this is a physical volume, so it has to go up. You can't have a negative volume. So we're actually differentiating it and putting it equal to 0. So, and they've told us to use differentiation there. So I'll just change colour because I'm changing question. So I'm not going to differentiate while it's in a bracket, so let's actually expand that. So we're going to have, well, I've got it written here, haven't I? So this is what I'm just going to rewrite it. So we've got 40 pi x minus pi x cubed minus pi x squared. Okay, so let's differentiate it. So with respect to v and x, so the rate of change. So it's going to be 40 pi minus 3 pi x squared minus 2 pi x. Okay, and we can put that equal to 0, so let's write that out again, equal to 0. Alright, well now we've got to just find out what x is. So, let's divide everything by pi. We can get rid of those. Just rewrite that because it can look a bit messy. Now you'll notice that these x terms I want to find negative. So what I'm going to do is put everything on, well, I'm going to put everything on one side because it's quadratic. So 3x squared plus 2x minus 4 is equal to 0. Alright, we're going to have to factorize this. It's double brackets because there's nothing common, but this is prime, so it shouldn't be too hard. Okay, so we've got options of 2 and 2, or 4 and 1, or 1 and 4, and we've just got to play around till that works. So if I put a 2, I get 6x, and no, that's not going to work. Let's put a 1 and a 4, this has got to work. Okay, no, that doesn't work either. Let's have a little think. Well, the reason is because that's a 40, and I neglected to put that in there. So now, let's change it to here. So we've got, so that's not going to be a 10 and a 4. So let's just rub those out. It's going to be 3x and x, but this is even more combos. So we have to really think. So you may want to use your alternative method that you have to doing this, where you write the factors of 120, but that's still going to be really quite messy. Okay, so let's go 4 and 10 again. It's just I always try the ones in the middle first. So if we go 4 there, this is going to work, because that's going to be 12x. It's always good to go relatively close, and I know the other one's 10, so I'm going to get it. So right, there we go. Okay, so what I have here is x is going to be to 10 thirds, and x is going to be minus 4, and I can immediately just cross that one out because it said the positive value. And there you go. All right, so x is equal to 10 thirds. That is where, so at this point here, that's where v is stationary. So C, we're gonna use all this information. So please check out the next video. Hope that helps.